video, we are going to look at the mathematical theorem for estimation of slope and intercept of a linear regression model. In my previous video, I have explained the concept of slope and intercept. Slope is nothing but the measure of steepness and intercept is the point where our line meets our y-axis. We have studied about the error terms, that is the residuals. It is nothing but the difference between the actual values and predicted values. So our error terms or epsilon look something like this. It is summation of I is equals to 1 to n by I minus a minus b of xi the whole square. Remember, a is your intercept, b is the slope. Now remember that we have studied by error terms have to be squared. There is a high chance the error terms may cancel each other out. How is that possible? Certain times, certain points would be above the predicted line or it may be below the predicted line. So these terms may cancel each other out and our errors become zero, which will nullify our results. Hence, we take the square of all the error terms so that they do not cancel each other out and we get the actual error value in our model. Now, remember, we wanted to fit a line which passes through all the points, but we saw that it is not easy to make such a line which passes through all the points in a scatter plot. Hence, the only solution out is to make a line in such a way that the distance of the points and the line is as small as possible. Whenever we hear that we want to make it as small as possible or we want to minimize it, one thing should strike our brains, that we have to go ahead with differentiation. So in this scenario, we will be using differentiation wherein we will differentiate first with respect to A and then with respect to B to find the values of A and B. So let's do that. Differentiating with respect to A. Remember, this is a partial differentiation. Hence, we are using dou over here and we are not using the D symbol. Because over here we are trying to find out the particular effect of a particular variable. So it is like a partial derivatives. So in this scenario, what happens when you take the partial derivatives of yi minus a minus b of xi the whole square, the 2 comes down because we have already learned that x raised to n derivation is nothing but n into x raised to n minus 1. So 2 comes down, so 2 reaches over here and then you have yi minus a minus b of xi and you have to actually multiply by minus 1 because the coefficient a has a sign of minus 1. But since we have a 0 on the right hand side, which is the basic rule of differentiation where f dash x is equals to 0, so the minus 1 gets cancelled out with 0 over there. So now let us open up everything. That is, we are taking the summation inside. Now the 2 also gets cancelled with 0. So you are left with summation I is equals to 1 to n by I minus summation I is equals to 1 to n and a. Remember, you are taking a summation of a number. Then what happens? That number is repeated as many times as n. So over here, this becomes nothing but na and minus b into summation of xi. Now let us go forward. So as I said in the previous part, the summation a becomes na and the formula remains the same. If you just look at this, something comes to our mind. That is, somewhere we are able to find out the mean of xi and yi. Yes, that's right. Now, if we isolate a, what do we get? We get na is equals to summation I is equals to 1 to n by I, this part, minus b into summation I is equals to 1 to n xi. Now, if you divide this entire equation by n, what do we get? Summation by I upon n minus b into summation I is equals to 1 to n xi upon n is equals to a. So we are slowly isolating a, and at the end, what is yi upon n? It is nothing but your mean. So we have a is equals to y bar minus b of x bar. So now we have got the equation for our intercept, which is nothing but y bar, which is the mean of y, minus b into x bar. Similarly, we have to find the value of b. In order to find the value of b, we have to differentiate it with respect to b. Differentiating with respect to b. So we have dou epsilon upon dou b. Again over here we are doing a partial derivative with respect to b, which is nothing but summation I is equals to 1 to n yi minus a minus b into xi the whole square, which is equals to 0, which is similar to the first order condition, which is nothing but f dash x is equals to 0. Now we bring this 2 down. So you have 2 into summation I is equals to 1 to n by I minus a minus b into xi into xi. Why is the xi over here? Because we are differentiating it with respect to b. So what is the coefficient left with b? That is xi, and it has a minus sign. But we are avoiding the minus sign because over here the minus sign gets cancelled out with 0. So your 2 also gets cancelled and your minus sign also gets cancelled. So now what you do? You open up the brackets. What do you get? So you have summation I is equals to 1 to n xi yi minus a summation I is equals to 1 to n xi, because your a is getting multiplied by summation xi, minus b into summation xi squared. Why is it xi squared? Because we are multiplying xi by xi. Now we have already found the value of a. We are going to substitute the value of a that we have found in equation 1. So what do we get over here? We have summation I is equals to 1 to n xi yi minus y bar minus b into x bar. This was the value of a that we have found, multiplied by summation I is equals to 1 to n xi minus summation I is equals to 1 to n xi squared. So in this step we have just inserted the value of a. Over here we have a, we have just replaced it by the value that we found in equation 1. After solving it, we find that the equation becomes summation I is equals to 1 to n xi yi minus summation I is equals to 1 to n xi y bar plus b into summation I is equals to 1 to n xi x bar minus summation I is equals to 1 to n xi squared, which is nothing but xi into xi. There is a reason in which we have written this in a particular way. We can club these two parts of the equation and we can club these two parts of the equation. After clubbing, what do we get? So we are going to take xi common from both these parts. So after doing that, we get summation I is equals to 1 to n xi into yi minus y bar minus b. We are taking minus b outside, so this becomes minus sign inside. So minus x bar over here and xi minus x bar, and we are multiplying it by xi. So we have broken down this xi. Over here we find a very similar equation. Now let us go to that equation. Now if you observe the first part can be written as summation xi yi minus y bar is equals to summation I is equals to 1 to n xi minus x bar into yi minus y bar. You will be wondering, how is the first part of the equation equal to the second part of equation? I will show you in a bit. So now if we open up the second part of the equation, we get xi yi minus xi y bar minus x bar yi, that is this part of the equation, plus x bar y bar. Now look closely at this part, that is summation I is equals to 1 to n xi y bar, and look at this part, summation I is equals to 1 to n x bar y bar. Why do you think I have cancelled these two parts? It's very intuitive. Now consider you have three numbers. You have 5, 10 and 15. What is the mean of these three numbers? It is nothing but your 10. What is the sum of these three numbers? It is nothing but your 30. So our first part is taking care of xi into y bar. So your summation xi, that is summation of 5, 10 and 15, which is nothing but 30. And what is x bar summation? It is nothing but 3 into 10, which is nothing but 30. How did we come up with this answer? Initially, we had studied about summation I is equals to 1 to n and constant. When you are doing a summation over constant, you get n into that constant. So similarly, in this fashion over here, we get that the sum of the elements, that is 5, 10 and 15 is 30 and 3 into 10 is again 30. So 30 into y bar and 30 into y bar is going to be the same. So we delete these two terms because these two terms cancel each other out. So I will repeat for everyone. Consider we have three terms. Our three terms are 10, 5 and 15. The sum of these three terms is 30 and the mean of these three terms is 10. So x bar is 10, summation xi is nothing but 30. Over here, our number of observation is 3 and we have studied that when we take the sum of a constant, we just multiply it by n. So n into x bar it becomes. So n is 3. 3 into 10 is 30. So our summation of all the observations and n into mean is equals to 30. So those two terms will become one and the same and they will cancel each other out. So we find that xi into yi minus y bar is nothing but xi minus x bar into yi minus y bar. This term is very familiar to us. This is nothing but your covariance between x and y. The same thing can be done on the second part of our equation. So in the second part, we have summation I is equals to 1 to n xi into xi minus x bar, which is nothing but summation I is equals to 1 to n xi minus x bar into xi minus x bar. Same way, same ideology which we used in the previous part, these two terms get cancelled, that is xi x bar and this is x bar the whole square. These two terms automatically gets cancelled and you are left with only the previous terms. So if you rearrange, you get this equation. So now over here we have reached the conclusion that summation xi by I minus y bar is nothing but summation I is equals to 1 to n xi minus x bar by I minus y bar, and summation of xi into xi minus x bar is nothing but summation I is equals to 1 to n xi minus x bar into xi minus x bar. So on rearranging the terms, we get that b is equals to summation of I is equals to 1 to n xi minus x bar into yi minus y bar upon summation I is equals to 1 to n xi minus x bar the whole square. The above equation is nothing but the covariance between x and y, and the below equation is nothing but the variance of x. So in this way, we have successfully found the slope, that is b, which is nothing but covariance upon variance, and the intercept, which is your a, which is nothing but y bar minus b into x bar, that is y mean minus b into x mean. I hope the derivation for a and B, that is your slope and intercept, is clear for one and all. Thank you.